Today we'll talk about scaling, and we'll compare the differences between being ready for scale and the unpredictability of scale versus not being prepared and losing opportunities. We'll also talk about scaling down, so full elastic scalability, when you don't need to be fully scaled all the time. In this demo, I spin up a lot of infrastructure. I have GCP App Runner, GCP Artifact Registry, a locally running application. This image will make sense shortly. And CockroachDB, first single region, then multi-region. And I'll be measuring the end user experience of CockroachDB via the application using an Apdex score. A latency of less than 20 milliseconds will gain a Apdex score of 1, meaning excellent. Anything less than 50 milliseconds will receive a good Apdex score. Less than 75 will receive a fair score. Less than 100 will receive a poor score. And anything over 100 milliseconds will class as unacceptable. First, I'll build my application. This will be a single region application, so it's not region aware. I'll build it locally. I'll create all of my infrastructure referencing that image. And the infrastructure we'll create is a CockroachDB cluster in GCP on our standard tier with 4 vCPUs. And I'm referencing the single region image that App Runner will execute. Let's apply that. The cluster is created. If I refresh my CockroachDB UI, we have our cluster here, currently just running in London. We're pushing the image, and once pushed, we'll start those app runners. With that done, I'll export some environment variables using the output of Terraform, so my CockroachDB URL and the URL to each of my app runner services. Now I'll create the workload table. This will be used to determine the number of workers in each region, so I can dynamically scale them up and down. I'll insert some data into there. So for each of our regions, we'll have 0 workers. And then finally, I'll create an account table. This will be a simple banking application and generate 1,000 accounts. Remember, this table is not multi-region. It's not region aware. Now with these running services, I can now look at their logs. So I'm using the gcloud beta run services log read, passing each of the regions and looking for the last 10 log messages. First, we'll see Asia Southeast 1. Next, we'll see Europe. And finally, we'll see the US. Currently, we don't have an Apdex score because there is no latency to calculate against. Our average latency is therefore 0. We're not making any requests per second, and there aren't any workers running. And this can also be seen via an HTTP call to their REST endpoints. No score, 0 latency. Now I'll run a simple application. It will get less simple. It will be a lot more exciting than you first see it. And this application allows me to scale the cluster up and down. First, I'll be scaling up in the EU region. Then I'll be adding US customers and AP customers. Bear with me, it will get more exciting. First, let's scale up the cluster. You can see in the logs, we've just published our scenario. And if I take a look at the EU logs, we now have 1 worker, give us a bit more space. We have 1 worker making 100 requests per second with an average latency of around 6 milliseconds and therefore an Apdex score of 1 because our requests on average are taking less than 20 milliseconds. Let's refresh. So around 5 to 6 milliseconds and our endpoint is returning an Apdex score of 1. Our users are happy. Now let's add US customers. And let's add AP customers as well. If I return the scores for these users, we'll see a different story because remember, we only have a cluster running in Europe and these users are physically situated in the US and Singapore. We see quite a different story now. Instead of 5 to 6 milliseconds, we're now seeing 5 to 6 requests per second with the average latency taking that cross-pond hop and back again of around 174 milliseconds. And our Apdex score is 0 now, which is unacceptable. A user in the US would not be getting an acceptable experience of the application. The story will be worse for users in Singapore because their requests are having to travel that much further. So we're making 2 or 3 requests per second and each request is taking nearly half a second, which is completely unacceptable. Now I'll show you how easy it is to scale CockroachDB across the world and bring those latencies right down and bring those Apdex scores way up. And the first thing I'll do is to update CockroachDB to be multi-region. And let's apply that now. So we're now applying that change. We're modifying the cluster. If I refresh the UI, we'll see that that change has already been made. And in a few more seconds, that change will be complete. And just 50 seconds later, our cluster is completely ready for global traffic, and the provisioned 4 CPUs that I originally gave the cluster are now being shared across all of the regions where that CPU is needed. I need to make a few changes to the database now to make it multi-region, and that's my bank database that I created through Terraform. I'll make sure that the primary region is set to Europe West 2. And this is for the bank database, not the default DB database. I'll make it aware of the US East 1 region. I'll also make it aware of the Asia Southeast 1 region. And note that all of these changes are happening online. There's no downtime involved. Each client will still be running. I'll update the table's locality to regional by row so that we can place leaseholders closer to the users who are actually making those requests. That's what's going to drive our latencies right down for users across the world. And this will take about 30 seconds. And because I updated the locality to regional by row, CockroachDB has created a hidden column called CRDB region, which by default will be the value of the primary region. I'm going to update that now to randomly distribute the rows across those regions. I'll build the multi-region Docker image and apply that to my app runners. Let's take a look at the database quickly, just so I can show you where data is being distributed. And with this query, I'll fetch a random row for a US customer, a London customer, and a Singaporean customer, and show you where their data is physically being stored, and more importantly, where their leaseholder, the thing that orchestrates their reads and writes, is located. For our US customers, our replica localities, i.e. the data, is being stored across all 3 regions. So if one of those regions were to go down, their data remains online and they remain online. And the same story holds for the London customers. Their data is spread across the world. You can pin data. I'm not pinning data in this instance, but their leaseholders are in London. And actually what we can see here in Singapore, their data is spread across the world for maximum resilience, but their leaseholders haven't moved yet. And we'll wait a couple more minutes for those leaseholders to make their way over to Singapore. With the database updated, I'll now deploy the multi-region version of the image. I'll now deploy the multi-region version of the application. With that done, let's take another look at the logs. So the EU worker still has an Apdex score of 1, average latency of 6 milliseconds with 1 worker, but this time the US also has an Apdex score of 1. It's making 100 requests a second with an average latency of 5 milliseconds. Let's also check AP. And the same story again, 100 requests a second, around 7 to 8 milliseconds worth of latency with an Apdex score of 1. So excellent latency scores all around. If you know me, you'll know I don't like to do things in half measures. So this isn't the only user interface I've created. I've also created a Wheel of Fortune style application scaler. Now what this will do is I can scale up and down any of the regions that I have. I can start a scandal. They're either very shy or they're having an affair. And this will reduce the number of workers in each region simultaneously by 5. I can release a new product, which will simulate interest in a brand new product by upping the number of workers by 5 in each region. Or I can start a flash sale, which will increase the number of workers in each region simultaneously by 10. Let's give it a spin. And we're creating a brand new product. So if I look for the number of workers and regions in the workload table, we've added 5 new workers to each region in addition to the 1 we already had running. So now we have 6 workers all trying to perform 100 requests per second against the database. Rather than going from the database perspective, let's take a look at the Apdex scores directly. We can see that the scores for each of the regions has gone down slightly from 1 to around 0.8 because the latencies are now hovering around the 33 millisecond mark. And that's because we've only got 4 CPUs for the whole of the cluster. Let's update the configuration to pump it up a little bit and see how that positively affects the Apdex score. And this is simply us reacting to scaling challenges that our application has, but we're doing it in real time. Let's double the number of CPUs and apply the config. Now this will be immediate. That change would have already taken effect. If we look at the Apdex scores now, we'll probably see something similar, but give it a few seconds and those Apdex scores will go right back up to 1 again. And there they go. They're starting to approach 1 again. The latencies are coming down. Now we're in the mid 90s. And there we go. Our latencies are slightly higher because we're making many more requests to the database now, but the Apdex scores are excellent again. And I was able to do all this with 0 downtime to the database and immediately. We'll give the wheel one more spin. And now we've scaled up EU again. So now we'll have 7 workers in Europe with 6 workers in each of the respective other regions, and we'll give it a few more spins. We'll scale up EU again. So now we'll have 8 workers, and this is all putting more pressure on the database. Let's see what that's done to our Apdex scores. So it's starting to come down a little, but not by much. We're still in the 90s. And this is where you'll want to monitor the performance of the database, the experience of the front-end users, and simply tweak the scale of the database accordingly. That's just how easy it is to scale CockroachDB Cloud's standard tier, taking it from a single region with a small number of provisioned CPUs to a much larger 3-region cluster with users distributed across the world in just a couple of seconds, allowing our business to very quickly respond to the changing dynamics of day to day. Give CockroachDB Cloud a try today and see how you can capitalize on the opportunities that come your way, whilst also scaling back when you don't need all of that capacity for maximum cost efficiency.